Alright guys, so just to go over how to complete the packet really quick, you can read the story about the gnome if you want to, and the sundials. So this is like the earliest use of trigonometry from the Greeks. And scrolling down, so what they did here is they made these two right triangles. You have one with the flagpole, so here's the flagpole. And then here is your meter stick. And they wanted you to measure the sides of these two triangles, and then we're going to see what happens with those sides. So, there we go. All right, so we're going to make sure you use centimeters, not inches. When you measure, make sure you are rounding to the nearest tenth. Don't round to the nearest whole. And when you start, make sure your tick mark is in the middle of the circle down here. So this one is about, I would say maybe 8.8. You could round to 9 if you wanted to. So I'm going to say that this one is about 8.8. And then, now to measure the hypotenuse, I'm going to say it's about 10.7 roughly. Is that what you got off right now? No? You didn't get 10.7?
I got for the hypotenuse was 7.2. Wait, no, I got 8.9.
Oh, you know what? Yours may be different at home because I'm using the smartboard ruler and you guys are using the regular ruler. So numbers are going to be off a little bit. And then measure the opposite, and that's about 5.8. And again, that is smartboard measurements, not real measurements. And then we're going to measure the meter stick. So you get about 4.7 on the smartboard. Measure the hypotenuse, you get about 5.7. And then the opposite, we get about 3. So, on the next page, you're going to just copy the measurements into the chart here, and we'll talk more about these ratios in a second. So the opposite side for the flagpole was 5.8, and we had 10.7, and 8.8. And again, copy the measurements that you get. You don't have to copy mine. You're going to do this on your own tomorrow. For the meter stick, I got 4.735. So 4.73 and 5.7. All right. So what happens next? We're going to talk about the trigonometric ratios. Just keep in mind that a ratio is just a fraction. That is it. So it's just a formula that has a fraction in it. So the sine is the ratio of opposite to hypotenuse. We abbreviate it as sin. On your calculator, you'll see the sin button. Cosine is the ratio of adjacent to hypotenuse. On the calculator, you'll see cos. Tangent is opposite. It's actually not hypotenuse. You can scratch that out. That is adjacent. So it's opposite to adjacent, and it's abbreviated tan in the calculator.
Are you busy?
I'm making a video. You want to be in my video?
Sure. Can I be it? We need help with geometry for the SAT.
Okay, hold on one second. Let me finish this up real quick.
Okay.
You're really trying to be in the video?
So the sin ratio, we have opposite over hypotenuse. Again, we're just going to leave it as a fraction. So we'd have 5.8 over 10.7. And again, I measured it on the smartboard. You are not going to have these numbers, but you should have decimals. Don't leave it as any whole numbers. Cosine, we have adjacent over hypotenuse. And then tan is opposite over adjacent. And that's all you're doing for this entire packet pretty much. You're just measuring the sides and you're writing them as fractions. I'm also going to measure the theta with a protractor. So, hello.
Hello, how are you feeling?
I'm not good. I'm not going to be here tomorrow.
Why are you calling me?
All right, so that angle is about 35. And that you can plug in. I think it does end up being 35 degrees. Notice how when you measure both of the angles, they're not going to change. And what ends up happening, so for the sin of theta, we get 3 over 5.7. Adjacent is 4.7 over 5.7. And tan is 3 over 4.7. Alfredo, do you have a calculator on your phone?
Yeah.
Okay. Type in 5.8 divided by 10.7. And I know I told you guys earlier to leave it as a fraction, but when you look at the
Shelley
decimal,
Watson, if you have not gone back upstairs to your room, if you come to Mr. Smith's office. Coach Watson, if you can come to Mr. Smith's office, please, ma'am.
okay. If you look at the fraction as a decimal, then you can see that something happens. So, Alfredo, type in 5.8 divided by 10.7.
You should get 0.54.
All right. What is 8.8 divided by 10.7? Point what?
182.
Okay. What is 5.8 divided by 8.8?
165.
Okay. Over here, what's 3 divided by 5.7?
152.
And what's 4.7 divided by 5.7?
182 again.
And then 3 divided by 4.7?
163.
Okay. And again, I kind of estimated the measurements here, but these decimals and this one's kind of nice. They do end up being exactly the same, okay? And this was actually on the performance final. If all of the ratios are the same, and again, they are the same if you were to measure exactly, then we can say that the triangles are going to be similar. And we actually know that because if you look at these two triangles here, this angle is 90 degrees, this angle is 90 degrees, this angle is 35, this angle is 35. So we end up having similar triangles because of angle, which we did talk about yesterday, which means all of the sides are proportional, which means that all of these ratios are going to be the same. And that will happen with all of these triangles that you do. So the sin, if I were to plug the angle in for this theta here, sin of 35 will always be 0.54, no matter what triangle you have. Cos of 35 will always be 0.82, no matter what triangle you have. No matter the sides, as long as you have that right triangle with a 35-degree angle in it. So scrolling on down and answering this question, based on what I just said, I kind of want you to write down your answer for that. And then number 4, this is what you're going to do today on your own. So just measure the sides, make sure you round to the nearest tenth. The adjacent side is not going to change. That one's going to be the same every time. I think it's 5. But the hypotenuse and the opposite side, they will change for every angle. And then again, don't worry about the actual angle measure because it tells you we have 15 degrees, 20 degrees, 25 degrees, and then you're going to write it as a fraction. Leave it as a fraction. And then we will finish this up. You're going to complete it tomorrow with Mr. Cassidy. So, have a good night, guys.